We're going to talk about 2023 January exam, question 2. Question 2, you are given the coordinates of 3 points, P, Q, and R. Part A, you need to prove that the angle PQR is 90 degrees. And then you are given another point S. This point forms a rectangle with the previous 3 points. Part B, you need to find the coordinates of S. Okay, part A. Even though the question does not require you to draw a graph, I'm going to strongly suggest you to draw a sketch. A sketch will help you enormously. You don't need to draw an accurate graph, just a rough sketch will do. P. Q and R. Okay, we need to prove that the angle PQR is 90 degrees. Let's draw some lines. As you can see, angle PQR does look like 90 degrees. But of course, you can't just prove it by saying, oh, it looks like 90 degrees. You have to solve it analytically. Well, having said that, you can still see that a sketch will help you visualize the problem. All right, so let's go ahead and prove this analytically. Okay, for line segment PQ, we know the coordinates of 2 points. We can therefore find its gradient. The gradient is change of y over change of x. What's the change of y? It goes from 7 to 11, so the change is 11 minus 7. What is the change of x? It goes from negative 3 to 9, so the change is 9 minus negative 3. This is 4 over 12, and it's 1 over 3. Similarly, we can find the gradient of QR as well, because we know 2 points. It's also change of y over change of x. What is the change of y? It goes from 11 to 2. The change is 2 minus 11. What's the change of x? It goes from 9 to 12. So the change is 12 minus 9. This is negative 9 over 3. And it's negative 3. Okay, we want to prove that this angle here is 90 degrees. It means PQ and QR are perpendicular with each other. We know that perpendicular lines have the product of their gradients being negative 1. Here we have 1 over 3. If you multiply that by negative 3, you get negative 1. So, because the product of their gradients is negative 1. So, PQ is perpendicular to QR. Therefore, angle PQR is 90 degrees. Okay, let's move on to part B. Part B, we're still going to draw a sketch. Point P, point Q, point R. All right, it says there's another point, S, that forms a rectangle here. So you can see that this S must be like somewhere here. So it forms a rectangle. Okay, rectangles have some properties. One of them is the opposite sides must be parallel to each other. So that means line PQ and line SR are parallel. Parallel lines have the same gradient. So that means the gradient of line SR is the same as the gradient of line PQ. We found the gradient of PQ in part A. That's 1/3. Similarly, these two lines are parallel. So the gradient of line PS is the same as the gradient of line QR. And we found that in part A, it was -3. Now, for line SR, we know one point. We know its gradient. We can therefore find its equation. Y minus 2 divided by x minus 12. This is change of y over change of x, and that's gradient. So we'll just have to tidy this up. And this is 3y minus x is -6. Okay, similarly, we can also find the equation of PS. We know one point, we know its gradient. So that is y minus 7 over x minus -3. This is change of y over change of x. That's gradient. Okay, let's go ahead and tidy this up. Y minus 7 is -3x minus 9. Again, let's tidy this up. 3x plus y is -2. Okay, we want to find the point of intersection, S, of these two lines. So that means we have to solve their equations simultaneously. Let's call that equation 1. And this one, equation 2. I'm going to multiply equation 1 by 3. I'll get 9y minus 3x is -18. I'll call that equation 3. So here, I'm going to add equation 2 and equation 3. And I get 10y equals -20. Therefore, y is -2. And let's substitute that back into equation 1. So I get -6 minus x equals -6. Therefore, x is 0. So the coordinates of S are 0, -2. We're done. Okay, let's go back to the question. So this question is basically testing you on gradients, straight lines, and solving simultaneous equations. Here, I have shown you, from my perspective, the most intuitive way to solve this question. This question is actually very interesting. As you can see, there are many different methods to approach this. In fact, some of you may come up with some quite creative ways to solve this, and they are also fine and very cool.